V naught to V naught. P naught already we have done the same thing. I'm pressure. So this is the so 1 mole of diametric gas undergo cyclic process 1, 2, 3. 1, 2, 3, 1 as shown in PV graph. Find the efficiency of gas. Okay, now you see that already we have calculated maximum temperature, no, for this particular thing, where the temperature will be maximum something. Let me come for efficiency. What is 1, 2? I'll have water. I'll have water. Meanwhile, okay, you can try this one. 1, 2 isochoric. Isochoric heating. So heat will be absorbed. What about 2, 3? Anybody? 2, 3. What process?
Here it is a general process, sir.
General process, nor isothermal, nor adiabatic, nor isochoric, or any other thing. It's a general thermodynamic process. Heat absorbed or rejected also, we are not very sure. That have to be calculated. 3, 1 isobaric cooling. So it will be rejected. We are not very sure. We have to calculate. We have to put effort. Okay, let's ideal gas equation. Let me take it. So that'll be easy for us. So 1 mole of monatomic gas. So shall we take temperature T naught? For our understanding purpose, this is. What about the temperature here? Will be 3 T naught. What about temperature here? Will be 2 T naught. Temperature of gas. Okay, now we have like this. What is a like we should calculate this particular thing, no? So first we'll do one thing. Area under PV graph, what will get it? Net work done. Area in PV diagram. So there's an area of triangle of into base 2 V naught V naught. Height of the triangle 3 P naught minus P naught. So this is P naught V naught. Positive or negative? Anybody? Positive or negative? Clockwise cyclic process, no, work done will be positive. Look at this clockwise cyclic process. So work done, net work done will be positive. Okay, somehow if we can calculate Q positive, problem is solved. So the path 2, 3 is what we don't know. So I'll proceed like this. Q23 equal to delta U23 plus W23 for the path 23. What is delta U3? It's independent of path, no? Change in intensity is independent of path. how the curve, irrespective of that, it depends only on final and initial temperature. Am I right? Sir, how you are writing 3 T naught, 2 T naught? I think by the time everyone 1 mole, let me assume temperature here T naught, 3 T naught, here 2 T naught. Is it okay by using ideal gas equation, the temperature of gases here? Shall I write or understood all of you? These temperatures, not given, we are assuming it. Or if you want separately here. Okay, delta U3. It depends only on initial and final state, no? So therefore, what we can write it as NCV T3 minus T2 plus W23. How to get W23? Area under trapezium. Area of triangle we know plus area of this rectangle will add up. Sum of these two is what? We'll get the area under the curve or trapezium will get it. So how much it should be? P naught V naught, 2 P naught V naught. Is it okay? Directly writing area under the curve 1, 2, 3. Please, I think in exams you can't draw so many diagrams, so it is better suggested directly looking at diagram you should able to make a guess. This is what W23. Am I right? Area of trapezium, if you want to, if you know how to calculate, you add it. I just know there's a triangle, no. P naught V naught plus P naught V naught. So 2 P naught V naught. Okay, let's substitute the next part. Or if you want trapezium, I'll write it trapezium formula of into height of the trapezium by half of the height plus sum of parallel sides. Okay, let's get into this one. Number of moles 2, monoatomic gas 3R by 2, temperature of gas at 3 is 2 T naught. Here it
A
is
diatomic gas, sir.
diatomic gas, so 5R by 2 then. Plus 2 P naught V naught. Get cancelled, so this will be 2 T naught minus 3 T naught will be T naught, so 5R.
Sir, it is 1 mole.
1 mole. Huh? Oh. So then how much will get it? 2.5. Negative sign also. Yeah. Plus P naught V naught. But what is RT naught? RT naught is what we assume, no? RT naught what we can write? P naught V naught equal to RT. That's for the assumption what we made. So therefore the next part of the problem will be minus 2.5 P naught V naught plus V naught. Look at Q23. It is absorbed or rejected.
So plus 2 P naught V naught, sir.
Oh, here 2 is missing. Huh? Yeah. So minus 0.5. So you may get a path where heat will be rejected and work will be positive. It all depends upon value. You can't say that everywhere. It all depends upon this one. So heat is here rejected. Diatomic gas, no, so fire by 2. Substituting these values, we ended up with this equation. So therefore now where all heat is absorbed, only in the process 1, 2. So what is efficiency? So what is Q12 will calculate. So I think I have to come for. So Q12 is equal to NCV T2 minus T1. 1 mole diatomic gas CV5R by 2. Temperature 3 T naught minus this one. So 2 T naught, so 5R. So it will be 5 P naught V naught. This is the heat absorbed. Okay, no, where all ET is absorbed, only in the path 1, 2. And we know network done. Can we get efficiency? Network done, P naught, V naught. Okay, 2 P naught, V naught only. By Q positive only this one. 1/5 or 20%. Okay, I think it's all about the formulas, no? We must know what is isothermal, what is adiabatic, what is isochoric, what is isobaric. So once you know all these formulas, no, you'll be in better position to analyze things. If you don't know what is isothermal formula, then not possible or nobody can do anything here. Okay, let me write the process name, so it'll be easy for you. There's a GTP. What is this? Isobar. This isochor. If you can identify the process and if you know the formula, it's over. And ideal gas equation. You can solve any problem here. Okay, I'll go for next part of next graph of different shape. Please, all of you put effort because there's a core idea of thermodynamics. Once you are able to solve this graphical problem efficiency, other things you can manage. They're just mere mathematics. You'll be very comfortable. Please do listen to your teacher's advice and try to implement